Common table expressions or CTEs are very useful, especially for developers, business analysts, marketing analysts, etc. Because using CTE, we can write complex business logic in the SQL itself. Now, if we have a very large complex query that handles business logic, then common table expression or CTE makes sense. Because let's say you have too many conditions, you have too many calculations, you have to use too many functions in a single SQL statement. So if you write it in one statement at a go, you might not get the expected result. So rather than doing it, you can break down the query using common table expressions or CTE and then do the calculations in these individual CTEs and then use joins to get the final result. Now CTEs are created as temporary tables which are the result set of the select queries that are mentioned in the CTE or common table expressions. These temporary tables typically are stored in memory. If there's not enough memory, it will be stored in disk also, which is fine because what you do using CTC is you break down the queries and put individual business logics in individual CTEs. Now, to talk about the syntax, this is how we create CTEs. We start with something called with, and after that, we provide the name of the CTE and then run as, and then the select statement. We can create multiple CTEs using with clause, and all of them should be separated by commas. Now, here in this particular command, I am showing you two CTE with two with commands or with statement, and then as followed by the select statement. Now, the last city should not have any comma as such. So, what it means that temporary table with the name city1 underscore name would be created with this particular select statement, and a temporary table with the name city underscore name would be created with the result set of this select statement. Once these two are done, then you can run select statement on the cities itself. So here, as you can see, I'm running the select statement and I'm using the common table expressions, two different common table expressions, and I can use the columns which are mentioned in common table expressions. We can think of cities as temporary tables or tables which are temporary and stored in memory. The moment the query execution is complete, the CTE tables will also be erased from the memory. Now, what would happen if we run this select statement is that the first result set would be created from this select statement and the result set would be stored in this name. The result set one can be thought of as a temporary table with the name CT1 underscore name. Similarly, the second select statement would be executed and the result set would be stored in another temporary table with the name CT2 underscore name. And this select statement will take input from both the temporary tables and then execute the query and give us the result. Now, of course, it's useful to look at an example. So I will present a business statement and will use common table expression to solve this business statement using SQL. What the statement says, we have to find the average lead time. The lead time is difference in delivery date and order date in days along with their average discounted price and quantity for customers across states. If you look at this particular statement, we have to find a lot of things. First is the lead time, second is the average discounted price, the third is the average quantity, but not for individual customers. We have to find it for customers across states, meaning that we'll have to find out for individual state. Obviously, there might be a group by statement across the state field, but before that, we'll have to calculate the lead time for each customer. Then we'll have to calculate the discounted price for each customer. Then only we can find out the average, because we do not have any row as lead time or we do not have any row as discounted price. And you might ask, why don't we store it in a different table? Of course, we can do that, but it is not advisable that you create tables for all the business statements, because then managing those tables would become a huge overhead. It would be a management overhead, it would be a maintenance overhead, so on and so forth. So that's why we have tools or features like common table expressions, materialized views, views, window functions, etc. What should be the approach? Now, this is what I think the approach should be. Of course, you can think of a different approach also. So, I'll create a runtime temporary table. So, when I say runtime temporary table, that means common table expression. Now, why it is called runtime? Because the temporary table would be valid, or would the life cycle of the temporary table on would be only during the query execution, meaning this temporary table would be created when the query is executed and destroyed when the query execution is done. So that's why common table expression is also called runtime temporary table, but it is famously known as CTE. So I'll create a CTE to calculate the lead time and discounted price for each customer. All the calculation would be done in that CTE. I'll use the results from the CTE and then join with customers table. Now you might ask, can't I run a single query or write a single query to achieve the result? The answer is I don't think so, because we'll have to calculate the lead time for individual rows. Then we'll have to calculate the discounted price for individual rows, and then we'll have to find out the average, which is not for individual rows, which is for all the rows. So we find out average for multiple rows. So here we need to find out the average lead time and average discounted price. So that would be for multiple rows, but the we do not have any column with average lead time and average discounted price. So I'll have to calculate that on a column by column basis. So that's why CTE makes a more sense, that we do that calculation, row level calculation in the CTE, and then multi-row aggregation would be done separately from the output of the CTE. So I'm connected to SQL Basics DB. Now, if you look at the business statement, I'll have to use both orders table and customers table. So this is orders table. We have order ID, customer ID, order date, delivery date, which is date data type, and then we have price and discount. So we'll have to calculate the lead time by delivery date minus order date. The discounted price would be price minus price into discount divided by 100. So let me just calculate it individually. I want to validate whether my calculation is right or not. The order date is 20th October 2025 and the delivery date is 2026. So this is 1045 days. So it was ordered on 3rd February 2024 and delivered on 14/12/2026. So I'm getting the correct lead time. So this says lead days. So what will I do is, let me go ahead and create a CTE. I'll name it as order details. So this is the CTE that I have created. Select customer ID, delivery date minus order days as lead days. Then price minus price into discount by 100 as discounted price. And then quantity from orders. Now one thing is that I'll have to mention as here. Sorry, I forgot that. Okay, so the CTE is created, and now we'll be selecting or joining this table with the customers table. So as this is done, now what will I do is I will run select statement, and here I will mention the state customer.state and then average of lead days, which is from order details, average of discounted price, which is also from order details CT, and then average of quantity, that is also from order details. And I'll have to join order details. I'll alias it as OD because that's what I have used, and customers, I'll alias it as C. Now, as I'm doing a join, this is an inner join, I'll have to mention the joining column also. So C dot customer ID equal to OD dot customer ID. Now this is the joining has happened, but I'll have to group by also. So group by C dot state. Let's see whether it works or not. And looks like it does. So it is showing us the lead time. I'm not sure whether it is average lead time, which one is lead time, which one is quantity, and which one is discounted price. So let's fix this a little bit. Now I'll have to cast this one also because I want to show it as decimal 10, 2. and as lead days. I'll limit as average lead days. Similarly, I'll cast this one, and finally I'll cast the quantity also. So now it is giving me the result, and I was able to get the result or generate the result using CTE. So this is the entire query of the common table expression, and this is the output. Of course, you can order it by average lead days or average discounted price, but this is how we use CTE. So as you can see, we have handled very complex business use case using the SQL itself, but we did not use a straightforward SQL. We had to take help of common table expression.